Hello, year 8. Today we're looking at volume and capacity. This will be the intro lesson. There will be a second lesson after this. Our intention today is to be able to solve volume and capacity problems. Success criteria will be applying the FSSU framework to solve volume and capacity problems. Right, our understanding of basic measurement and units of measurement will also come handy with this lesson. Let's look at a three-dimensional solid. Now, a three-dimensional solid takes up space. For example, this cube here of dimensions 1 centimeter by 1 centimeter by 1 centimeter, then the volume is simply equal to 1 cubic centimeters. So volume will be equal to 1 cubic because the volume is simply 1 centimeter times 1 centimeter times 1 centimeter. And that gives us the 1 cubic centimeters. The same thing applies to a solid, a 3D solid of dimensions 1 meter by 1 meter by 1 meter. The volume is simply 1 cubic meter. Later on, we'll explore the relationship between the cubic centimeter and the cubic meter. Now, for any 3D object that we have, if it is a prism, it will have a uniform cross-sectional area. So here, the face which is shaded will be our cross-sectional area. But for a shape like this, each of the faces could still be the cross-sectional area as well too. Cross-sectional area means that if we were to cut this object by that face, everybody will get the same kind of slice, the same shape, identical shape, and that's why we call it a cross-sectional area. So this shape, this cuboid, can have that as a cross-sectional area, it can have that, and it can have that as well. The same thing applies to the cube. Each of the faces could be a cross-sectional area. For a cylinder, we can also slice it along it's the parallel line to the base, and each slice will be a circle. So for a cylinder, a cross-sectional area will be a circle. Now, how do we do volume calculations? Now, in this very simple example here, you can basically count how many cubes make up this shape. As you can see, it's made up of 4 centimeters, which is 4 blocks, by 2 centimeters, which is 2 blocks, and by 3 centimeters, which is 3 blocks. So if you counted the blocks, you'll be able to calculate the volume occupied by this. But mathematically, we use the formula length times width times height. That's the formula. Length times width times height, abbreviated like LW and so on. So here our length is 4 centimeters, our width equals 2 centimeters, and our height equals 3 centimeters. So in problems like this, you extract all the information which is given to you, and then you go to the formula and you do the substitution. So FSSU means you write the formula down, you do the substitution, and then you simplify, and then you attach your units. Right. So it is 4 times 2 times 3, and that gives us 24 cubic centimeters. Right. And for those of you who probably watching this for the first time, FSSU simply means formula substitution simplify and units. It's important that you have a structure in solving your problems. Now, if you look at this problem again, you can also see that we could have calculated this by the formula A multiplied by H, where A is the area, because, for example, if I look at this shaded part here, so this volume will be equal to the shaded part, and the area of the shaded part is 2 times 3, which is 6, multiplied by the H, which will be 4. And that gives you volume equal to still 24 cubic centimeters. So you can always make use of your cross-sectional area and multiply by the height. In this case, is the length, but it's because of the orientation of the object. The object could have been sitting on that shaded part, and that length would have been called the height. So the length and the height are relative in terms of how you have your shape and the orientation of it. All right. So looking at this prism we have here, you can see that you can divide it, and this pentagon shape would be the cross-sectional area, and the cross-sectional area is given to us as 12 square centimeters. So again, the formula for volume will simply be that, and we multiply, we do the substitution here, and so 12 multiplied by 7, because this height, which is the length here, is 7. So you multiply this cross-sectional area by how much of it you have, and that gives you your answer, which is your simplified and your units. So the FSSU is being applied in solving these problems. It gives you the structure to show you're working out. Right. What about this one here? As I said, today's lesson is the intro, so it's very basic. If your year 7 measurement was good, you should find this very, very easy for today. So here, what is given to us is always important when we do measurement questions. When we have diagrams, we write down what is given to us. Well, we know that length L is equal to 11 meters. We know that the width W is equal to 2 meters. And we know that the height H is equal to 5 meters. So all that we need to do is to write our formula equal to L times W times H. And we do the substitution, which is going to be 11 times 2 times 5. Well, 2 times 5 is 10. 10 times 11 will be 110. And what is the unit? Cubic meters. The unit is cubic meters. Right. Let's look at the next one, volume of the prism. Now, we can see that the cross-sectional area is 26 cubic centimeters. So again, we can write down cross-sectional area A is equal to 26 square centimeters, and that will be the height. H equals 8 centimeters. So the volume, let's write down the formula, which will be A multiplied by H. Then we'll do the substitution, which will be 26 multiplied by 8. And then we would simplify. Now, if you couldn't do 26 by 8, all that you need to do is to grab your calculator and just perform that operation. But 26 by 8, that just gives us 208. 208. 208. And the unit is cubic centimeters. Cubic centimeters. So the cross-sectional area we have been given, multiplied by that H, and that gives you the volume of the shape given to you. We'll do the same thing with that. We've been told that the cross-sectional area A equals 15 square millimeters, and we've been given the height as 12 millimeters. So our volume will be A multiplied by H. We'll do the substitution, which will be 15 multiplied by 12. And we would need to do that calculation where we have 15 multiplied by 12. And that gives us 180. And the unit is cubic millimeters. Cubic millimeters. Remember, when you write a number, to also attach the units. Attach the units as well. Right. Now, in this question, we've been asked to shade the cross-sectional area of the shape. Well, if you look at it, the cross-sectional area is triangular part. That will be the cross section. That's the way you can divide this shape so that everybody will get a triangle. So it's been shaded. We could have also shaded the one at the end there. Right. What's the shape of this cross section which has been shaded? Well, it is a triangle. A right-angled triangle. Right-angled. Right-angled triangle. So calculate the area of this cross section which is shaded. Well, the area of a triangle is base times height divided by 2. Now, what is given to us? Let's write that down. Given. Well, the base is 8, so B is equal to 8 centimeters. And the height is 5. So H equals 5 centimeters because that side is the same as that side over there. Okay, so let's do the substitution. So A will be equal to 8 multiplied by 5 divided by 2, and this will be equal to 2 go there, 1 and go there, and give you 4, and 4 times 5 is 20 square centimeters. So that's the area of the cross section. So since that's the area, we can now find the volume. So the volume is simply A times H. So in this case, we know that H is equal to, that will be that length over there. H is equal to 9 centimeters. So our volume equals 20 multiplied by 9, and that will be equal to 2 times 9 is 18, so 180. And the unit is cubic centimeters. So 180 cubic centimeters. 180. So first we had to identify the cross-sectional area and then calculate what that area is and multiply by the H to get the volume. A cylinder won't be any different because the cross-sectional area is a circle. We know that the diameter is 6 centimeters, so the radius must be 3. The height is given as 10, so all those things have been given. The volume of the cylinder is A multiplied by H. Let's use capital H for that. Doesn't matter whether it's small letter or capital letter. So A times H. The A is pi r squared because that's the area of a circle, which we've already done area of a circle, pi r squared. And then we multiply by H. But we know that R is 3, so we substitute for R, which is 3. So it becomes 3 squared and times that. And you can use your calculator to simplify that to get that answer. Remember, the unit is very important. The unit is very important. Right, at this point, you can pause the video and copy these questions into your math books. And once you've done that, you can solve them. The answers are at the end of this video. So please don't get to the end. You need to copy the questions now and solve them in your math books. Thank you very much. Do the same here as well. Let's pause the video, copy into your math books, and answer them showing you're working out. Answer them showing you're working out, please. Thank you very much. Again, let's pause the video, copy the questions into your math books, answer them showing you're working out. Thank you very much. Right. So in today's lesson, we looked at volume and capacity, and our learning intention was to be able to solve volume and capacity problems. This was just the intro lesson I said to you. Our success criteria was to apply the FSSU framework to help us solve volume and capacity problems. Additional work and extension work for today's lesson was very basic and simple. It's just to complete all the questions in this lesson, and make sure that you're drawing your diagrams, labeling them where necessary. Additional work, you can also look at your online homework on Education Perfect. And as I've said, during remote learning time, doing homework is optional, although my expectation will still be that you will find in some time to do some of the homework. That will be very useful in developing your skills. Thank you very much. And of course, don't forget to subscribe to my YouTube channel if you've not, so that you can get notification of videos that I post regularly there. Thank you very much. The channel is Tabi Maths. Finally, these are the answers to the practice questions. So again, you can pause the video and you can mark your work. Please, if you do not agree with any of those answers there and you can fix your errors, please just do so. If you so disagree with the answers here and they don't match what you think they should be, please post your query on Google Classroom and I would answer it for you there. Thank you very much. Thank you for the lesson once again. Good luck and bye for now. Thanks.